And we'll be back in, thank you, 1 minute after this video talking about batteries, energy storage of the future.
Battery demand in Europe increased by almost 40% between 2021 and 2022. A plateau in battery installations is expected in the next 3 to 4 years due to a lithium deficit, before growth will return towards the end of the decade. Batteries are considered a key piece of the energy transition puzzle, but challenges and limitations remain. For starters, how can we ensure that batteries will be part of the solution and not create a new problem? Key concerns include supply chain issues, how to sustainably source materials, and the opportunities and challenges presented by emerging technology. Learn more in our next expert panel, Batteries, Energy Storage of the Future.
Welcome back and welcome to our next panel discussion, Batteries, Energy Storage of the Future. For the next 45 minutes, we're going to be learning about future use cases of battery storage and answering the question of how we can guarantee sustainability and use batteries to add flexibility and stability to clean energy systems. And to do that with me, I have 3 experts. So firstly, we have Anna Schneider, VP of Product Management at Sonnen. Anna entered the renewable energy sector after nearly 6 years of consulting and product management in banking. She's worked at Sonnen for 5 years, focusing primarily on energy products and internationalization. Anna, welcome to the virtual stage.
Great to be here.
Thanks. And joining her, we have Dr. Lennard Wilkening, a CEO and co-founder of Suena. Lennard is an esteemed expert in power engineering, specializing in battery optimization and power markets. With a PhD in electrical power engineering from the Hamburg University of Technology, he has now accrued over 8 years of experience in energy storage optimization. Welcome, Lennard.
Thank you, Greta.
And last but not least, we have Joseph Ciccone, who's a consultant at Apricum, the cleantech advisory. With a strong foundation in both technical proficiency and corporate strategy, Joseph's expertise spans various critical areas, including mobile and stationary battery technology, green mobility, green hydrogen, as well as model analysis, product strategy, venture building and fundraising. He began his career as a researcher at the Paul Scherrer Institute and is now at Apricum. Welcome, Joseph.
Thank you, Greta. Pleasure to be here.
All right, so let's go straight into the topic. Joseph, when it comes to energy storage, the 3 main forms are chemical, thermal, and mechanical. Could you give me a brief overview of these 3 forms and explain why chemical is the most common? And then after that, long question, more specifically within chemical batteries, why does lithium-ion have such a large market share?
Absolutely, yes. Thanks very much for the question. Happy to kick things off now and look at the bigger picture and specifically highlight these 3 main areas of storing energy that you mentioned. So electrochemical, mechanical, and thermal. Electrochemical, what do we mean there? So essentially, that's where we have electrons paired with a chemical counterpart. And these could include the group of technologies that we refer to as lithium-ion based. And yes, it's important to bear in mind that lithium-ion is a group of technologies. But of course, there's a whole zoo of other things out there based off, for example, lead acid, sodium, potassium, nickel, hydrogen, flow batteries, and of course, also power to X to power. So for example, hydrogen storage in this capacity in this category as well. For mechanical, that's basically anything that we kind of drive a form of motion or physical process. So pumped hydrogen, compressed air, or flywheels. And then finally, thermal. This is kind of a conversion of electricity to heat, so through heating, phase change, or also through a chemical reaction. So it's all well and good, but very important to bear in mind that actually about 96%, so the vast majority of energy storage that we have globally is in mechanical storage, in the form of pumped hydro, of course. And that's great because it has a very high kind of maximum power output and a very high kind of absolute energy capacity. So you can imagine this big reservoir at the top with your energy, and it's rushing down all at once to have a high max power output. But unfortunately, we can't really take pumped hydro around with us, so we need something else. So enter batteries, and batteries have a very much higher specific energy capacity. So there's many more electrons that you can fit into one place. And just to get round to the real crux of your question without going off too much on a tangent, why lithium-ion? Well, lithium-ion particularly has a very high energy density, about 10 times that of lead acid. And they've kind of won this race, if you like, because of, first of all, economies of scale, and that is a decrease in cost. And second of all, because of their performance. So we're now seeing them being built at scale, and yeah, they're also supported by many other kind of government grants and things, which are now enabling us to be the clear choice in terms of using these for both stationary and mobile applications.
Thanks, Joseph. Very comprehensive answer there. I've learned a lot, actually. Anna, going on from this, when we look at the proliferation of lithium-ion batteries, do you think we should be putting all our eggs in one basket, so to say? Or, in your opinion, are there other viable alternatives?
Not to me now. Well, from a residential storage point of view, I think that should be lithium-ion for the time being, because it's just the most developed technology. As Joseph pointed out, there are other technologies out there that, at least for what we are doing, and if you look at the smaller scale batteries, it just doesn't make a lot of sense. I'm not sure whether Lennard has a different view on that from different perspectives, but yeah, at least the opinion I have when it comes from a residential perspective, I think lithium-ion is for the time being the chemistry of choice.
Lennard, did you want to add anything there?
Yeah, I can add that I agree absolutely with lithium iron phosphate there. Actually, because we need batteries at a scale right now for the energy transition. I mean, for home storages, also for large scale storages. So that's the main point. I mean, of course, we have also sodium. It's a really interesting technology, but it's not there yet. And also like flow batteries, which are maybe for more durations, so more capacity. We can go for longer duration storages. But at the moment, for the energy transition, we need definitely for EV, but also stationary, we need a lot of iron phosphate, and they are really already there.
Yeah. Mm-hmm. Thank you. And Joseph, going more into the chemical side of things as well, recently significant development is being done in the field of anodes in addition to cathodes. Can you tell us a little bit about this and what sort of repercussions this could have on materials and supply chains when it comes to battery storage?
Absolutely, yes. So in terms of the cathode and anode development, so the cathode is houses the material which has the lithium component in, and it's generally more complex. So this has been generally the focus of kind of technological advancements up to this point. Also because it has a higher cost component on the cell level compared to the anode. So about 50% more or less of cost on the cell level goes to the cathode, as opposed to about 10% goes to the anode. What we're seeing now, though, actually is the anode material, which is pretty much universally standard as graphite, is becoming kind of a limitation to increasing the energy density. And anode, this graphite material also has some other drawbacks. So, for example, China has almost a complete monopoly over graphite supply, controlling, the vast majority of the supply chain. And it's been made worse by recent announcements where they've actually restricted supply in some cases. So you need a permit now to export graphite. So what does that mean now? Well, basically everyone's thinking about where are the alternatives, especially here in Europe. So there's some other options, luckily. So these are things like silicon composites, pure silicon, and lithium metal. And these things can really increase the some of the properties of your battery. So decrease the size while increasing this energy capacity, and also things like fast charging, which are obviously very important. And critically on that, the supply chain point, silicon is actually pretty ubiquitous, so it can be found on most continents. So it's an opportunity there to kind of capture that, some of that upstream supply.
Thanks, Joseph. And going on from that, supply chains, sustainable sourcing of materials, Anna, how can we ensure a circular lifestyle and sustainable materials in this process?
I think there's still a way to go in that area. Quite a long one, but I think especially in 2 areas, right? We can already in product development look at that aspect, but then also obviously in the relation to our suppliers. When we develop new products, we should really have a look at what materials are we using, right? On the one hand, what types of raw materials, for example, we just don't use any cobalt, which is even worse than lithium. Still, lithium isn't great. So the other aspect is you can use as much recycled raw materials as possible, right? There is already a step in the right direction with the EU battery regulation, forcing the manufacturers to do it. I think it makes a lot of sense, because only a joint movement can make a difference at the supplier side. If one manufacturer decided to use recycled lithium all by themselves, they probably couldn't get their hands on it. So I think that regulatory development is going into the exactly right direction. And then last point on the product development side is you can design your products in a way that they can be disassembled easier after usage, right? So to enable further recycling after that life cycle. And then, I mean, the other aspect, obviously, are suppliers. You just need to check them as good as you can. You need to check what sort of sustainability criteria do they fulfill. You need to have regular conversations with them, how important that is. And you need to get close to them in order to not only understand the way they operate, but also to understand their respective supply chains. It's not an easy task to fulfill, but then there are also third-party companies popping up that help you with sorts of certifications that you might ask your suppliers to get. So.
And just building on top of that, in terms of knowing that you've got sustainable materials, talking to suppliers, what sort of responsibility do consumers have in ensuring that the product that they're buying is sustainable, and how can we kind of make that process easier?
Well, I mean, it's just like in any other product that consumers can buy, right? There should be sort of mechanism. I mean, as a consumer, you can only look for that sort of proof with the manufacturers that you can choose from, right? I mean, right now there is also with the regulation, there's this battery pass, and then I think it will become over the course of time more clear who are the manufacturers who look into those sorts of topics and who maybe less, and then criteria will develop over time to make them more comparable also amongst each other, right? But right now I agree it's not super easy, and you got to look carefully if you want to choose the right battery as an end customer, especially I think in that context, because in many cases you don't choose yourself, but you're choosing what your installer tells you.
Yeah, thanks. And Joseph, you mentioned a little bit before about graphite and a few other materials, and that has some repercussions on Europe's relationship with China as well when it comes to manufacturing. Do you think we need to push for more domestic competitiveness in Europe? and reduce dependence on China for battery manufacturing?
Sure. Yeah, I think absolutely. We do. As with a lot of other clean tech, China has positioned itself in a very strong position on many parts of the value chain. So I talked a bit about anode and cathode active materials, but also, of course, on cell production, module production and integration, they're very strong. And don't get me wrong, I think, I want to say that part of the story of the economies of scale and rollout of lithium-ion has been the decrease in price and the massive kind of scale up from China. So they're a big part of the story about why we've seen prices decrease in about a half over the last 5 years or so. But what's important to bear in mind for us is the sheer value of this market. So the European Battery Alliance estimates that it's worth lithium-ion value chain in Europe about 250 billion euros in 2025. And, the EU auto industry accounts for about 7% of all jobs in Europe. So about 13 million jobs. So this is real big stuff that the value that we want to try and retain here in Europe is incredibly important. And we do see that slipping. We do see EU automaker sales slipping globally, being taken over by Chinese competitors. So of course there's things to be done, and that has to start on the European level. And we are now seeing flagship policies come in to try and make sure that there are certain material requirements that are being built up in Europe. So on Monday, I think there was the European Commission struck a deal to enforce the Critical Raw Materials Act. So this covers lithium, natural graphite, and silicon metal, and a particular amount of those to be extracted, recycled, and processed within the EU. So that's certainly a good start, but there's a long way to go.
Yeah, absolutely. Thank you, Joseph. And Lennard, I know this isn't your area of expertise, but do you have anything to add on this matter?
Well, as Joseph said, and again, so there's a long way to go to really establish the gigafactories here in Europe. And so I would just add again that, of course, there are the big players in China like CATL, BYD, which are having a really high market share for lithium iron phosphate. But I would again just add that we really need now this gigafactories all around the world, also in Europe. But if we look into what we need in Germany or in Europe as large scale battery capacity, it's definitely not possible to wait for gigafactories now here in Europe.
Mm-hmm. We've had a question from the audience, which I might direct to you, Joseph. Is there any way to bypass the issue of materials that are being mined?
If there is, I would love to. I'd love to know what it is. I mean, we can wait long enough, and maybe something arrives on an asteroid from space. That would be interesting. But no, I think that it is really an essential part of this industrial complex. We're moving away now from an oil-based economy to economy that is based off of electrons in a large sense in the power industry, and there's a lot of other materials that we need to make that happen. And of course, we all know that some of the biggest criticism of this endeavor are the fact that we will need increasing amounts of those materials, lithium being one of them. But that for me is certainly a challenge, and it is an unavoidable challenge. And I'm confident that the ecosystem that we're building up in terms of having strong ESG standards, having strong recycling ecosystem will be able to achieve that.
Thanks, Joseph. And we've had a couple of questions from the audience asking about hydrogen. So it seems to be a bit of a burning topic for a few of our viewers. Joseph, I might also direct this to you, but anyone feel free to jump in. If lithium-ion batteries are the most important ones in terms of the energy transition, how come hydrogen gets more and more attention in the media and from politics?
Sure. Yeah. No, happy to take that one. And thanks for the question, because no discussion is complete without a what about hydrogen question. So I'm glad we touched base there. And yeah, I think in terms of energy storage, hydrogen is likely to play a part. Right now, it is incredibly niche. As with a lot of aspects of the hydrogen industry at the moment. I'm a keen support. I mean, I worked in electrolysis, and I see now some of the projects that have been announced, and it's very exciting. But I think when we're talking about energy storage, Anna mentioned earlier in her sector that she looks at in residential, there is really only one winner for the majority of use cases. Where hydrogen has some very interesting use cases is, for example, for low annual cycles and high discharge duration applications. So that's what they kind of refer to as seasonal storage, which is one thing that lithium-ion can't do. But it will be very interesting to see how that sphere develops, as with other types of technologies, which can also do things on the longer scale that maybe lithium isn't so good at.
Anna, do you have anything to add to that?
Not really. I think it always just has to be a mix of things, right? I don't think that there will be only one technology that dominates it all, but for different use cases and applications, you will need different solutions. And hydrogen certainly has its part, but it will not be the one technology that can take over everything, for the limitations that Joseph just mentioned too.
Mm-hmm. Thanks. And Joseph, what are some of the challenges of scaling up battery production from tons to megatons to, even as Lennard mentioned, gigatons? What are some of the key success factors and some of the unique challenges in Europe?
Sure. Yes, absolutely. All the small questions for me today, but absolutely happy to take them on board. And this is one, of course, we get at Apricum from some of the key players in Europe looking at this, because it's not an easy one. That's for sure. You know, how do you scale up? There's a lot of moving parts. So important things to bear in mind just on the manufacturing and supply chain side are, you know, ensuring that you have a timely and cost competitive supply of raw materials and production equipment. Actually designing and operating your plant can be very challenging, especially if you don't have experience in that. Hiring a skilled workforce, and this kind of constant improvement of making sure, I mean, it is a very competitive space, you know. You have companies who are putting down billions of dollars into their R&D and into their production process. So if you want to enter that sphere, you have to be basically prepared to fight. And, you know, it is a struggle to make sure that there's enough share of these raw materials to go around. So there's some of the broader topics. One other thing I would just mention, and this goes actually again back to something that Anna said in the beginning, is about this kind of starting back at the product design phase as being a way to actually increase the ease that you can ensure supply of these raw materials. So design choices, for example, what cell chemistry do I use, or what form factor do I use? So this might mean that you can actually have a greater pool of suppliers in the future, and you won't find that you've designed a product that actually you're very restricted in the type of options that you have available.
Thanks, Joseph. And Lennard, you talked a little bit about this before of, you know, reaching gigatons. What do you think is the necessary capacity of large-scale batteries in Europe to facilitate the energy transition, and how can we actually get there?
Yeah, thanks for the question. So actually, we estimate at the moment, or is estimated, that we need around 50 gigawatt of large-scale batteries in Europe till 2030 to enable the integration of renewable energies. So, and yeah, to compare it, so we were just able to deploy around 5 to 6 gigawatt now of large-scale batteries in Europe. So there's still a lot to achieve and big challenges ahead of us. So that's why we need batteries at a scale at the moment. And yeah, talking about the optimal size of a battery, of course, this depends very much on the use case. Looking into like large scale batteries, utility scale batteries, of course, we have this co-located batteries, which are co-located with renewable energies, solar or wind mostly. And of course, then the size depends on the grid connection point, on the peak power of the solar or the wind farm. So this is one size. And on the other side, we have the standalone batteries, which are directly connected to the grid, which are stabilizing the grid with different use cases. And what we see at the moment is batteries from the power side, so from 1 to multiple hundred megawatts installed. So for example, in Germany now a 300 megawatt battery is planned with 600 megawatt hours capacity. So this is a really big battery, but the average is maybe in between 10 and 50 megawatt at the moment, what is deployed. And if we even look to other countries like US or Australia, we see already like gigawatt batteries and gigawatt hours. So it's becoming more and more bigger assets. And the duration, and that's also talking about hydrogen or more long duration storages. So at the moment, what's the best business cases for batteries which are having a duration of 1 to 2 hours? In the past, we only installed like 1 hour batteries with a 1 hour duration because we use them more for really short-term application, like stabilizing the grid, reacting to the grid frequency to balance the active power in the grid, which is quite important. But for this, we need more like short-term, like 1 hour durations. Now, since batteries are entering the power markets, we see more and more 2 hour durations. So what means that 1 hour duration, 2 hour duration? So 1 hour means we have a 1 megawatt battery and 1 megawatt hour of capacity. And the 2 hour system is like 1 megawatt with 2 megawatt hours capacity. And so the optimal size at the moment, even if we look into the future with price curves and market dynamic curves, we see mostly 2 hour systems are the most profitable. And for example, hydrogen, we would use only for much longer durations because the efficiency from power to power, like creating hydrogen out of renewable energy and then creating power out of it, it's so low that you cannot really integrate them into like power trading, for example. But of course, if we have like days of no sun or no wind production, we would need more gas power plants, and of course we could also use hydrogen there at some point. But I would say the best or the optimal size at the moment is like a 2 hour system.
Thank you very much, Lennard. And Anna, how can batteries be integrated into energy systems to be used as a flexible asset?
I won't explain exactly how technically it works, but we are doing that already, right? We integrate them through software. We virtually aggregate residential batteries into one large, then more or less commercial sized battery. It's our virtual power plant, and we steer then the single assets as a big asset, right? And so even the small residential batteries can serve the same purpose that Lennard was just talking about, and can help stabilize the grid. We're doing that already in Germany, Italy, Australia, and through partners also in some other markets. So even the small kind of anyways there batteries can have that second use case, and then can be used instead of only the large systems that need to be then put somewhere next to the production system. But we can use all those assets and all the flexibility that is out there and has been installed by end consumers in order to serve the same purpose.
Thanks, Anna. And we've had a question from the audience directed towards Lennard. Do you think EU countries will have a problem transporting large amounts of energy when using old grids?
Could you please repeat?
Sure. So someone from the audience has asked, do you think EU countries will have an issue transporting large amounts of energy when using old grids?
I mean, the grid infrastructure in general, of course, is a big limiting factor right at the moment. In Germany, in the EU, so almost everywhere. So of course, if I get the question right, but of course, this is also something we would need batteries for to of course like enhance the grid infrastructure, which is, for example, not yet possible in Germany. For example, if we install a battery in Germany, if we're looking for installing a large-scale battery in Germany, the best position is where the infrastructure, the grid infrastructure, is the strongest, because there are no limitation to the operation of the battery, and therefore the business case is the best, because we have no like flexibility market or any revenue opportunity by positioning a battery where it's really needed, maybe in the north where the grid is like overloaded of wind power here in Germany as an example. So there needs to be much more development from this perspective, that we really use also batteries not only, for example, power trading, which is more like a global market, like also using it for like grid supporting local application use cases. Yeah.
Thanks. And you just mentioned power trading. Which use case do you think shows the most promise for ensuring batteries are used as a flexible asset? So energy trading, virtual power plants, or what do you think shows the most promise?
Yeah, that's a good question. So actually, we are always saying that the battery is more the Swiss Army knife of the energy transition. So we can really use it for so many different use cases. And it's really interesting because other than the Swiss Army knife, then the battery really has the potential to excel in all of these use cases, because it has a high energy density. It has a really fast reaction times, very good efficiency. And it's just about the software now. So it's not anymore about the hardware. It's really about the software, how we can use the battery and how efficient we can use all the batteries. And we also always say that batteries are more or less software-defined assets, or energy storages in general. The better the software, the better the quality of the operation and also the returns. So it's really much about the software. And of course, we have all the local use cases, like the locally means like if we have grid problems, as I just said. So peak shaving is one use case to reduce the energy consumption cost for example, commercial and industry. We have, of course, the use case also more on the home storage side. It's self-consumption optimization, which is quite interesting and profitable. Of course, we have a lot of grid supporting use cases. We can use them to stabilize the voltage, backup capacity, black start capacity. Also interesting if we have a blackout to rebuild the grid. Batteries can be very good use for this. And also, which is becoming more and more a topic again, is virtual inertia. So it's actually also discussed here in continental Europe, but mostly in Great Britain, since it's an island grid, and they're having much more challenges to stabilize the grid when they have a high integration or high share of renewable energies like wind. Because in general, if we have conventional power plants in the grid, they're having the rotating mass of the generators and the turbines, and which is stabilizing the grid. And now we have the energy transition going further. We're losing this conventional power plants, this inertia. So batteries are also able to offer a virtual inertia, because they can react super fast in milliseconds to changes in the grid. But there's also no revenue opportunity. And that's why I would say still the most promising use cases are, on one side, the ancillary services. So to stabilize the grid, there's like the FCR market, frequency containment reserve market. So if we have an imbalance between power generation and demand. The battery reacts directly to the frequency. We have another one is the secondary control reserve, is AFRR, which is also a really good revenue opportunity for batteries, and it's quite important for the grid. And then on the other side, since now we are seeing more and more volatility in the grid because of the higher integration of renewable energies and more forecast errors. And of course, this is also the hypothesis why we need batteries. Yeah, because to integrate the renewable energies, and we can see it on the power markets that we have this volatility. So I would say the most promising use case is now power trading, flexibility trading with batteries. It's just starting, and we really need them to transport the green energy from midday in the evening hours to react to all the forecast errors. And so I would definitely say flexibility trading on power markets is the most promising use case. Yeah.
Thank you, Lennard. Very comprehensive answer there. And we've had a question from the audience asking, or noting first, we've observed countries like Italy or Spain organising subsidies or even specific mechanisms accessible only for long duration stocks, 4 to 8 hours. What's the view of the panel on trends in different EU markets? Pretty long question, so maybe I'll direct it to you, Joseph, first.
Sure. Yeah, absolutely. I think first of all, I could speak more to the, storage market in the UK, since it's the most developed market, and I think a lot of Europe look to them really as a role model to the type of business models that exist. And what's happening there is, as Lennard mentioned before, 1 hour and now 2 hour duration is kind of standard. But we are indeed seeing kind of an extension to that to 3 and 4 hour systems. And the interesting thing there, and this is how Lennard actually ended, was to say that it's not so much of a technical limitation of the battery, but more of a requirement for there to be a revenue stream to have that kind of mode of operation. And what that requires is the fact that the energy markets and regulations need to facilitate that type of play into the market. And that's very much still a work in progress. We're getting to see this in the UK, in Spain, in Italy, but also in places like Texas in the US, where they have their own kind of regulations that can facilitate this type of trading.
Thanks, Joseph. Anything to add, Lennard?
No, I absolutely agree. If we're looking into, we do a lot of analytics on the business cases for Germany and UK also, and so the added capacity after 2 hours, which is of course increasing the capex of the investment cost for the project. This is not like aligned with the more trading income so far, and that's why of course we need like support for longer duration storages much more than for shorter ones, because for the shorter ones we have already an interesting business case. Anyway, the business case is one of the major challenges for large scale batteries, since there's not much security there in Europe. So for example, the standalone storage, in GB we have kind of a capacity market, which gives a bit of a security on the investment, but mostly the business case depends on the markets, and therefore on the dynamic of the market, on the market prices. So for example, for the ancillaries, if we look into FCR, they are different called in UK, it's DCD MDR, but in general it's the same mechanism. And the volume of these markets is like limited. For example, if in Germany we can only participate in 750 megawatt market. So it's of course it's limited. If we need gigawatt of batteries, they cannot all participate there. So we have fluctuations of the prices, saturations, and that's why there's always a risk involved in the business case if we look into batteries, and we definitely need to stabilize it. That's the main reason.
Thank you. And shifting a little bit more towards residential batteries, Anna, what are some of the major barriers to more widespread adoption of residential batteries, such as price, and how can we break these barriers down?
I think honestly, price is a barrier, but I think it is also a decreasing barrier, right? As we talked about before, the prices have gone down, and I think on the other hand, the cost for electricity is going up. And the prices for electricity will be more dynamic over the days, right? Lennard was also talking about the spreads on the electricity markets now. More and more countries are introducing either time of use or dynamic sorts of tariffs, and these types of tariffs make it even more attractive to own a storage system. So I think the residential batteries are actually winning over time in attractiveness, and therefore I'm not sure that we need to lower the price. I mean, obviously it's always better to lower the price to make the business case better, but it's, on the other hand, from my point of view, extremely important to focus on two things on the batteries. Not only to offer the cheapest possible, I don't think that should always be the main goal, but it should be a safe system, because I think this is actually one of the biggest barriers. If the batteries aren't safe, and if more incidents happen with residential batteries, then that is going to affect the adoption massively. And then secondly, it's about the software and the intelligence of the batteries. If you can use your residential system, for example, in FCR markets or in spot markets, then you can make so much more revenue with it than it cost initially, that it's worth the investment. And I think as long as the business case works, then it's not necessarily only a question about lowering the price as much as possible. So I think it more has to do with the adoption of PV in general, making also PV and storage accessible for more people, in the sense that you need to have regulations or let's say blueprints for how to do this in condominiums and not only in single family homes, because right now, at least in Germany and in many other markets, this is very much limited to single family homes. So everyone who's not living in that sort of luxury can also not participate in that sort of market and go into PV and storage. Maybe then, making it available for, as I said, more types of homes, but then also space to some extent, right? And now bringing the batteries outside helps in some markets. I mean, again, having the very German perspective, sometimes our basements are very big, the batteries can stay there, but that's not the case in all countries, right? And having smaller systems or outdoor rated systems make it then sometimes easier to install them. So I think those are a bit the considerations that I would have to encourage a higher adoption of the residential systems. It's not only price, from my perspective.
Yeah, absolutely. Thank you, Anna. And for our final question, we've had a question from the audience, which kind of brings in the large scale versus small scale debate. They ask, wouldn't it be better to bypass the bottleneck of grid capabilities to decentralize the whole energy transportation system to more smart distribution on a local level? Anna, maybe first up, do you think that would even be viable to have a completely decentralized system when we're talking about energy storage?
So I would like to say yes. I don't think yes is the right answer, so I'm saying no. As much as possible the right way, yes. So absolutely, right. We're talking doing things local in so many regards when it comes also to climate change, and I think producing the energy where it's needed is a perfect example for that, right? Use the grid as little as possible in a way, but I'm sure, I mean, there are applications where you just can't produce the energy locally that you need, right? Not every factory, not every, I don't know, train can produce the energy exactly where the item needs the energy, right? So it's definitely the right direction, and we should, as I said, produce the energy as locally as possible. It will not be 100% like that, and I think the buzzword of smart distribution then is the right one, right? We need to get there as much as possible, but it can't be 100% achieved.
Lennard, what are your thoughts on this?
Yeah, I mean, I absolutely agree. Maybe just to add, so in general, a system, the energy system is much more stable if it's a big system. So if we look to GB, which is an island grid, it has much more trouble now with the energy transition compared to the continental European synchronized grid, because it's a big grid which is supporting each other. So that's why I was also looking into it. We called it the cellular approach, like having cells, decentralized cells, which are like more or less able to supply each other and to stay independent, but always being synchronized again at some point. So, but as I said, the grid is much more stable if it's a bigger grid. And also we have, of course, to keep in mind that we have these wind farms. We need also the big wind farms in the north. We need some places where we have big solar farms, and we need to somehow transport this energy to make the energy transition possible. So it's definitely both. We need to optimize on the local level, but we need also a very stable and good grid to integrate like large scale of wind and solar.
Thanks, Lennard. And Joseph, your final thoughts on this?
Yeah, absolutely. Just from me, I would compliment and say, reiterate the fact that these type of solutions, especially this decentralization, is enabled by the software development. And especially when we look at, these, recent boom in kind of machine learning capabilities, we have some very interesting solutions which can enable the amount of data which is out there now through things like vehicle to grid to vehicle. Let's not forget about the amount of batteries that are going to be, filling up our roads soon and can also be utilized as well as stationary residential. So yes, absolutely. I think it's a very exciting field indeed.
Thank you very much. That brings us to the end. We're a little bit over. Such an interesting debate there. But thank you to the three of you for the really insightful discussion. I definitely learned a lot, and I hope our viewers did too. We'll be back in a minute after this video talking about scaling and expanding energy tech. Thanks, guys.
Thank you.
Thank you very much.
Bye-bye.